Hey, am I audible? Hey, can you hear me? Okay, so we'll wait a couple of minutes to join. Some of us are still joining, so let's more people join. So we have a couple of people here, so I think we can get started. So it's already 3:07, so not any more time. So, uh, hi guys, my name is Anoop. I'm working in NVIDIA. So I'm a 2014 pass out from Electronics and Communication Department, School of Engineering, CUSAT. So I got placed in a company called Broadcom when I passed out in 2014. and I worked there for around 2.5 years, and then I got an opportunity with NVIDIA, and since then I'm working for NVIDIA as a senior engineer now. So yeah, so uh, it's nice to see you all. Uh, Hope you all are safe. So today I'll be mainly talking about the industry, and as a representative from the industry, I would like to just give you an overview about how things happens in industry, how things are going on there, the uh, current trends that is going on in the technology, then the basic challenges that you'll be facing, that you should be prepared for while mm, going for a career in the industry, and other miscellaneous stuffs like your expectations about the industry, the gap between the industry and the academia, and stuff like that. So, uh, as a engineer who is working for like 6 years in the industry, I know it's a very less experience compared to a lot of other people who have dozens of years in their career. But the things that I have learned in this past 6 years is like the most important thing that you should have is the you should be adaptive to change. I mean, while coming out of the college and getting into a company like Broadcom, which is a huge player in the uh, fabless semiconductor industry, then I actually realized that what we are learning in the college and what we are doing actually in the industry, there is a huge gap between it. Yes, obviously the basics that you are learning in the college, the basic understanding, the basic concepts still really matters. But more than that, you should be learning a lot of new things. So the one thing that you shouldn't stop is keep learning. So more and more things you should be, so every single day you should be learning new things. So still I'm studying a lot of things every single day. I'm learning new things every single day, which will help me doing my works, as well as understand more things better in future. So that's one of the most important thing that you should understand, that you should keep learning. It's not a process that come to an end when you get out of the college. It never gonna end if you want to keep up in the industry. So uh, then another thing is like it is fast moving. Like the things that you studied, most of the things that you guys will study in your syllabus will be kind of obsolete by the time you get out of the college and start working on it. So I still remember learning like transistors and stuff, all those things during the college time, and a small introduction about MOSFETs or something. And when I get out of the college and start working on these things, the transistors we use this term still, but we don't use transistors or even MOSFET anymore. We use FinFET and more advanced technology that is being used in the industry. So it is much fast moving than you ever imagine. So by the time you get out of the college, the industries whatever you're going to work on will be much far ahead than what you've learned. So the only way you can keep up with that is by learning things and be open to new knowledge. So and still it is like when I started my career in Broadcom, I was started working on a system on chip. uh, so I was working on 28 nanometer technology, which is the chip was made. And now the latest chip that I worked on, which launched 3 days back, it is it is fabricated on a 7 nanometer technology. So the whole thing is actually moving so fast that we are also sometimes carried away by that fast moving industry. And another thing that I should say as a challenge is that things can change very fast. Like even if we are working on some technology, any new breakthrough or any new research outcome that can cause a breakthrough can change the whole thing that you're working on. Like the whole thing, the electronics industry itself is mainly working based on something called Moore's law. You might have heard it. You should have studied it. It's not a law, but it's kind of an observation that Gordon Moore did during the 1960s, that the number of transistors will get doubled every 1 year, and the cost of the devices will be coming to half. And later in 1975, seeing the explosive growth in the future, they actually revised it, saying that number of transistors will be doubling in every 2 years, 24 months, and the price of the uh, hardware will be coming down as half. So till a couple of years back, we were pretty good at holding that move slow, because we were moving that fast. We were moving from one process node to another very fast. But last couple of years, if you see, you can observe that the speed of the hardware or the number of transistors of the hardware is not increasing that much according to the Moore's law. So we are not saying that Moore's law is completely coming to an end, but we shall explore more technologies to keep up with that. So currently, the latest chip I said that I worked on, it is fabricated with a 7 nanometer technology, and we have packed around 54 billion transistors in that single chip. So that's one of the biggest GPUs in the world, and the fastest. So moving forward, if we try to pack more transistors to squeeze out the maximum performance as needed, it is physically become more and more difficult. So if you think about a basic transistor level, say the width of the gate, if it is much lesser than 7 nanometers, say 5 nanometer, or going down, then more and more quantum level complexities will come into picture. So you might have heard something called quantum tunneling and stuff like that, which will actually have a lot of uh, implications in this manufacturing. So, is there any scope for reducing the node below 5 nanometer? So, even 5 nanometer is not in production yet. So, I think IBM and Samsung have started some risk production on that, but in a consumer level or a product level, it is not yet productized. So whatever you have, all the consumer electronics have till only till 7 nanometer. The problem is, while going down, there are a lot of other things that come into picture. So for an example, if you have a 14 nanometer or a 12 nanometer chip, you have this high and low voltage domains, which actually means the voltage that you needed for switching on and off these gates or these transistors. So as the process goes down, that voltage domain also goes down. So previously in a say 14 nanometer or 28 nanometer, if you needed 1 volt as a high and say below zero point 0.5 volt treated as low, so that is coming down, and the difference between this low and high is coming more and more closer. So the effect of noise in these circuits will be much higher than previously in previous designs. And even if you go down less than this 5 nanometer, gate will just turn on without any power source. Something other process called quantum tunneling will happen, so the electrons will just go through the gate without being given any voltage. Tunneling is something called quantum tunneling. It's not just literally tunnel and go, but the electron will disappear on one side and appear on the other side, which can be explained based on quantum physics. So there are a lot of physical restrictions that we have to keep up with this more slow, but we are trying to get around with it by implementing more different technologies like three-dimensional stacking, and there are some etching technologies that we use, like we have this extreme UV processes that help us to etch more and more smaller scale. So we are trying to keep up with that with new technology, and more research is also going on. But uh, because of this explosive growth, now customers or the end users also will be expecting to have more faster hardware in the coming years. Definitely, you will be expecting to have a faster phone uh, next year or next to next year. You won't be upgrading a phone unless it is having a much performance upgrade, a much performance increase than what you are usually using. And the one thing that people are never tired of is, or never get enough of, is faster. You will never think, oh, your phone is so fast or my computer is so fast. No, you will never think that. So how much fast you can get, you will just go for it. So because of that, you actually what we are doing is we need to explore more ways that we can implement or we can use in this technology to get around this problem. So one thing, so there are several options that will proposed by the scientists and all, like quantum computing, or we have like carbon nanotubes, stuff like that. But for that, we are still in the early research phase, and we cannot say in coming 15 or 20 years that will be productized to use from a consumer point of view. So we are at this point, say in 2020, we can say that we are standing on a junction where this Moore's law is kind of getting saturated. At the same time, in the technology field, you can see the fields like AI and deep learning is thriving. So more and more things that you used to do uh, regularly using manual or using normal programs or normal softwares are now done by artificial intelligence or deep learning or neural networks. And another important thing is that these kind of applications like like deep learning or artificial intelligence, this requires a huge amount of hardware resources, high speed hardware you will be needing. And that speed is the same thing that we are bottlenecked due to this saturation of the Moore's law. So that's why we are coming up with stuff like accelerators, like specific purpose processors or devices that can do some specific operations at a very much higher speed, like this tensor cores TPU. So Google have launched a TPU, and we NVIDIA have several HPC chips. So the last one we have launched is Ampere A100, which is specifically targeted for high performance computing. So for getting around this problem, we are actually trying to develop different kind of hardwares that can accelerate specific type of operations. So like mixed floating point operations or stuff like that in much faster than normal processor or normal uh, microprocessor would do, and try to do it in a centralized way. So suppose if this deep learning and all this artificial intelligence stuff, it needs a lot of data to train on it, and based on that training, the it will come up with a model, and that can be deployed and used in your devices. So what happens is, if you have a phone and you want to do something which is powered by AI, it is not necessary that the complete resource that is necessary for running that, or necessary for uh, processing that should be there in your phone. There is already a trained model that you can run on your phone. You can do the job. So that training, that main part can be done in a cloud or in a centralized server, and you can do that and make use of that model in your personal devices like computer or phone or wherever, so that you can make the you can do this job. So currently, one of our most moving markets is high performance computing. So we actually power the most top five supercomputers in the world, and luckily, I got a chance to work on those chips, which is being used for these supercomputers and this data centers. And uh, it is like we have to find some way like this to meet the requirements that is coming up from the world. So all this started at some point where this Moslow is getting kind of looking for saturated, and what we found was this GPUs, or a graphics processing unit, which is actually a parallel processor which used for image processing. So image processing, uh, you know that it needs a huge amount of resource to process all these images or render videos and all those stuff. But if you think in the base operation, that is actually matrix operations. So I think if you are in your syllabus, there is image processing in fifth sem, or I think it's third year or something. And you know that all these image processing operations are basically, if you go to the deep level, it's just matrix operations. So these GPUs are actually designed to uh, do this in a much faster way than any conventional processes. So if we find a way to represent whatever data we have, so for whatever things you use it, if you can represent that in a matrix format, a GPU can do it. So in basic level, what GPU does is matrix operations, and then it renders it and make it a picture or a video or whatever it is. So in bottom level, it doesn't know whether it is going, the output is going to be a picture or some rendering or some animation or whatever. But in the basic level, what it does is just calculations, raw mathematical operations with matrix. So any data, if you can represent that as a matrix format, you can make use of the power of this GPU. So it all started with that thought, and now we are doing the same thing. And now what we are doing is we are optimizing, designing specific hardware, optimizing it for do the, just this data operations. Does a hardware engineer working on such accelerated chipsets need thorough understanding of real language maths and how it's in NVIDIA? So basically, if you're, I'm not sure what you think about work going on in the company, but it's if you take our company as an example, it's not just engineers there. It's not limited to electronics engineer or a software engineer or anything. We have physicists, we have mathematicians, we have statistical experts, we have CGI artists, we have all these experts in all these areas where this product is going to use. We have all these people in our company, and we develop all these things together. So it is not necessary that you should understand about deep learning or AI to work on a chip or a system on chip or a GPU that is going to be an end product targeted for this market. For example, the amount of knowledge about deep learning and AI for me is much, much, much lesser than a normal computer science student, a college student should have. Uh, because I'm not my daily work won't affect that, because it is like it is a huge project. Suppose if you are making a GPU or something, it's a huge project with 10 thousands of people working on it, and the thing that you'll be working will be very limited. Suppose there will be a block in that hardware which generates the clock and distribute towards the whole operation. I may be working on just that block, and what are the inputs, what are the outputs, how that clock should behave, all those things. Only that may be the thing that I should take care of. So it is like you can if you want to know, there are, you can know, but it is like you if that is your responsibility, that is the thing that you should do, and everything related to that you should understand, and everything else is kind of a black box. I mean, it's not necessary to understand it, but you can go for it, you can understand, you can ask people who know that stuff, they will tell you, and you have things to read and understand internally, you can do that, but it's not necessary to understand all these things. So yeah, it is like, can say, this is a hardware, I mean, artificial intelligence hardware company that I'm working on, but I don't know much about AI. Just the basic shallow things, that only that. My expertise is on the hardware level, the block level, and that may be something generic, not specific to a GPU. Or it can be used with a CPU or any other stuff like that, SoC or something like that. So there's no restrictions, there is no hard rules, like you need to understand everything, but it is good to have an understanding, a basic level understanding, that what you're working on is why you are doing it. What if you get a requirement, it is good to understand why that requirement is coming, what is the use case for this, and stuff like that. So so this major challenges like this, we are trying to solve using new technologies, like introducing new way of doing things like tensor cores and specifically designed hardware blocks to do these specific things in a much faster way. And another thing is that we so I mostly work on post silicon part of this. Like, around 70% of work I do in post silicon, and around 30% I will do in pre silicon. So the whole term is devised from a fact that we use silicon to manufacture these chips, but as I said before, because of the physical limitations, we may go for different materials and different processes. So the whole term may go obsolete, like silicon. So we refer the chip as a silicon because it is made from silicon, but there are other materials that research are going on which can replace the silicon. So all those changes, it's not it won't happen in a very sudden way, but in coming a decade or something, you will be moving from the traditional electronic devices manufacturing from entirely something else. We may not know still, because any research or any breakthrough invention can change everything that fast. So, as I said, I'll be talking about this industry and how to keep working on an industry, like learning new things, stuff like that. So, even if you are working on things like this, like it's always better to understand more things which is going on inside as well as outside your company in the industry, which will help you definitely to go further. So learning about this stuff, like what is going on, what kind of technology you're using, and what your competitors are working, and all those things. So share the journey into VLSI. So to be specific, I'm not exactly in a VLSI domain, I must say. So yeah, it's like our org is ASIC, but I'm mostly work on post silicon stuff. So VLSI, you can, I mean, the core design is somewhat different. I'm not in core physical design, but if we generally say, so how I got into the industry, the first thing was the stepping stone was I got placed from college itself in a company like Broadcom. So things that helped me getting that is mainly my interest towards the field. So yeah, I used to study what's there in the syllabus, and like everyone, it is like it was much better during the initial semesters, and the graph keeps falling when we move to more semesters, and at the end of it, it was like there are papers like you just pass or you have backlogs. But it's not about the things that you learn in the syllabus, but about the skill set that you have acquired during that period of time. So for acquiring those kind of skills like knowledge about this microprocess, hands-on experience, so one of the most important thing that you should know is practical experience. You should you should do things to learn that. Like I have done like PCB designing, etching that PCB and make that PCB, circuit designing, and even I've even done all this embedded programming, everything. So what require for this mini projects and projects, we do it our own, and definitely we won't succeed in all the stages. We will fail. We'll fail. We have failed miserably. And even the main project, I still remember we were targeting a hardware prototype of some image recognition system, and at the end of the day, we didn't have any hardware that is prototyped, but just the concept. But what matters is how much effort you are spending, how much research that you are doing, how much things that you are learning in the process of achieving it. The end result, it doesn't matter. So you should understand things in the basic level, why it is happening, why this is needed, and all these things that you will understand only when you start doing stuff. Like you start doing designing hardware. So we used to do everything our own, like designing circuits, then converting that design to PCBs, making each that PCB, then solder it down, program it, use it. Everything we were doing by our own, which actually helped us a lot in learning these things rather than just understanding the basics based on the syllabus. So that is one of the most important thing, and that definitely I can say that helped me a lot in getting into the industry. And another thing that I used to say everyone who is working in this field is you should learn programming. If you don't know, you should definitely learn it. It doesn't matter which language you learn, whether it's C or embedded C or Python or whatever. It doesn't matter. The language is just the way how you translate your that algorithm or a logic to the machine readable form, or that just uh, just the way we use normal languages, just uh, for communicating with the other one. But the learning the programming will help you in developing that kind of thinking, the problem solving skills, looking at a problem in a real life scenario, in a like actual case, and you should be thinking about all the possible solutions and find a way to uh, extract one specific solution which is feasible based on the other constraints. So this is exactly what we do in the programming. As so, if you learn programming in any language, definitely that will help you uh, to get into the industry, definitely, because that is one of the most important thing that should be used. Even if you are a hardware designer, at some point you will be using some sort of coding or programming or scripting to make things easier for you, or make more things to increase your productivity or stuff like that. I still do. I mean, even if my core area of work is hardware, I still do a lot of programming for automating and all those things. Like we used to take signal measurement in oscilloscope, the frequency measurement, and all the analysis. Initially, you do it manually, and if you want to do this thing recurringly in a lot of hardware things, definitely we have done scripting and automated all these things, and so that you can do it in a single click, and your time you can use for other productive stuff. So definitely programming, if you are an engineer, whatever engineer you are, programming definitely is one of the most important things that you should know. So there's nothing to worry about if you are not say okay, I'm not that good at programming, I don't know programming. It's not that difficult. You can always learn it. It will take some time if you are not familiar with programming or something with some specific language, but definitely if you keep trying, it is much easier than you think. And once you understand the programming in any one of the language, then you can learn whatever language you want based on that industry. So how were you in the college? When did you get serious for your career? So I was like, I was always fascinated by the technology, the gadgets, and all those stuffs, and I liked science from a very early age. I was much fascinated by the science, especially physics. So from my school age itself. So I was because of that I chose this computer science specifically during my high secondary, and I was into programming. So all this from that time onwards, I always thought that this will be the industry that I'll be ending up, and I did as I thought, because it was just the interest that I had, the drive from within, which just never stopped me from asking questions and learning more things. So just Google it, and if I have a doubt, I'll just Google it and find out. And the things that I learned like that are the more things that helped me in this journey than what I have learned from the syllabus. But I'm not saying that it is not important to understand or learn from the syllabus. It is important. All the basic core concepts which you are learning are important. As an example, I should say, after around 2.5 years of career in Broadcom, and I attended the interview in NVIDIA, they asked about the operating regions of transistors. I mean, I have never even thought about it after coming out of the college, and that was the first day after that college that I thought about operating regions of transistors, because it was something that we learned in the basic. I mean, even we start during the physics in +2, and then first year and second year. And after that, we just go more advanced things like op amps and amplifiers, and more and more high level things, and we tend to remember the basic stuffs. But luckily I got that. I remembered that, and I am able to answer it. But it's just let you know that how important it is, because it's just not in the questions. When even after I started working, right, if we end up in an issue, and if you are trying to understand how that issue is coming, you should have a thorough understanding about the basic things, like the, even the more basic things like the operating regions and transistors and stuff like that. So what I'm saying is, it's much important to understand the basic concept which is in your syllabus, but that is it is equally important to learn more things which is outside the syllabus, which you will be using eventually when getting into the industry. uh, how will this pandemic and coming recession influence the future of graduates and advice and solution? So one thing is that yeah, it will be a slower process than before, because we are in a very uncertain situation. But if you think the other way, everyone is sitting at home. The people like me are working from home, or everyone is doing these things remotely, and that itself need a huge amount of infrastructure, from the internet, from the servers, from the hardware, everything. And we need technology related to that. So whatever happens, that things are needed. So if you let me tell you from our perspective, from our company's perspective, from recent times, this is the time where our markets are going really high, because we are doing a lot of things which is helping people during this time. So we are helping scientists to research on these things and finding vaccines and all those things. We are helping researchers to find other things. So it is like a lot of things, lot of infrastructures, and you need more people will be using this internet and all these servers and like social media sites and all the backend data centers were run with our GPUs. So that is also need to be scaled. So if you look in that perspective, it is never going to decline. It will definitely need a lot of people to work on, a lot of things to work on. And I must say that from my experience and what I have seen, the core companies, they are not going back on this recruitments, or they are not freezing anything. From the core company's perspective, it is actually a good time for the industry. A lot of things needs to be done, and a lot of industries like IoT and all are doing a lot of stuffs to help these people during this pandemic and all these things. So it's definitely there is nothing to worry about it. Things may get little slow, but I don't think it's a that bad time. So keep up the hope. Definitely, things will get much better, and we'll be okay. There's nothing to worry about. So yeah. So then one thing I've been telling was definitely the gap between industry and the academy. As I said before, you should learn about the basic things, but the major practical applications that you'll be using when getting into the industry, that is, in my understanding, it is nowhere in teaching in this syllabus or anywhere. So you should actually read things. You should Google, just Google it. Just Google the things. Just search things that is going on in the world, the new technologies, the new things that is happening, and just read and say, watch videos and document this. In YouTube itself, we can see a lot of things, which is a lot of advancements or researches or new technologies that is being developed in the world every day. So you should understand that, you should learn that, and you should keep up with that. And by that, you can reduce the gap between this industry and the educational system. Where what is you're missing out in the educational system, you can learn by yourself, because it is like you can now through internet you can get everything. So if you want to learn something, there are like online courses available uh, through like edX, Coursera, Udemy, Udacity, all those things. There are a lot of functions. So only thing that you should have is a drive to learn things. So only thing that you need is that. Otherwise, all the resources that you need is just available on the internet. You need to spend time, you need to understand things, you need to learn things. That will definitely help you in getting into your career. So what extra skills are required to join the scientist training, like in software or language? So it is like one thing is the basic core concept that should be there, and whatever extra you have, whatever extra software or tools or languages that you know will definitely help you. So one thing in my personal understanding, personal experience, is that Python helped me a lot in my whole career from start till now. It's like it helped me a huge amount that I could do my job much more easier. I mean, it made my life much more easier. So there are things like that that you should learn. Definitely it will be used in the industry, and it definitely will help you out. So uh, now things, the times have changed. Even I think in Kerala state syllabus itself, they are teaching Python language in their in IT paper. So uh, the time that I first heard about Python, or I first started using about Python, is actually after coming out of the college. Till that, I have no idea what Python is or what this language is. Only thing was I knew some languages like C, C++, and VB when I was in the college, which I used for some projects and stuff. And I learned this thing after coming out of college, but it helped me drastically. So a huge amount. I cannot explain how much, but that much it have helped me. And tool software and tools, definitely. There are a lot of like if you are a core designer, the whatever you only thing you can access is the free tools that is available. but the basic understanding of that tool is enough. If you are going for a bigger tool or bigger things that only industries use, which is much costly, your basic understanding of this whatever free tools that you have used will help you a lot in speeding up the process. So definitely, if you are into the design field, the basic design softwares that is available by, there are a lot of open source software for even if it is good designing, PCB designing, VLSI, or whatever it is. There are a lot of free tools. Just try those, uh, do some small project with it and get familiarized with it. And what are new tools that you will be seeing in the industry, that definitely you can learn by your own based on this experience. So yeah, definitely. So what you will be learning in the syllabus will be just the basic stuff. You just consider it as just the foundation of these core concepts, nothing else. But how to apply that concepts in a real life situation, in a real life problem, or in a real life project, that you need to understand, that you need to learn, because a lot of new things are coming in. You need to learn all that by yourself. So I don't think anywhere near this will happen like the syllabus will be revised. So definitely we are revising the syllabus to incorporate more and more things, but I don't think it will be on par with the industry in any way, because industry is moving that fast. Even people in the industry are actually in that it is difficult to cope up with that speed. So definitely the academia will be slightly behind. There will be definitely a gap between the industry and the educational system. That is expected, but you can reduce that gap as much as possible. That only you can do by learning things by yourself. As a hardware engineer, do you spend most of your time in lab or in the computer? So I used to spend most of the time in the lab only, because what we do is on-board stuff like measuring, like a lot of things like that, things like you do in your electronics lab, high-level things of that. But based, because we know now for like 2.5 months I've been working from home, and all these things what I used to do physically there I'm able to do from here. It is because of the automation, as I said before. The measurements that we used to do in the scope and all, we automated it. We were running scripts and we get their data. So once setting up is needed, but everything else we can do it remotely. So it is like it's not always you need to be physically present in the lab to do that. But I always feel it's much easier to be present in the lab, because if something is there you can directly do it, like do the connections and all those things. Now we need to figure out some ways, and we are using a lot of devices to remotely access, using a lot of like things like relays, remote power controllers, and remote control relays, and then muxes and all those things. So a lot of things that we use additional just to avoid being physically present in the lab. But eventually, we are actually moving towards the automation that most of the things that we should be doing will get done from the laptop itself. But it's not completely, around 70 to 80% of the time only. Remaining you should be physically present and doing the stuff like we do in the electronics lab. You may burn things, you may screw up things, but you'll learn. So, so yeah, I think I have covered most of the things that I was planning to cover today. So it's mainly about things like. So I hope that you got a overall picture about the industry. It is not like it is too difficult to get into. It's not like that. It's based on how you learn things, how you develop your skill sets, and yes, you should be having a basic foundation, a thorough foundation, on top of which you can build up all these skills and all these uh, skill sets. So that is one most important thing. And I'm not sure what were your expectations when you think about a career in the industry. But one of the most thing that I want to share with you is that it is very much exciting to work with companies and work with technology like this, because you are being a part of a huge thing that is going to be used around the world by a lot of people, a lot of industries, a lot of institutions, and you're helping a lot of people indirectly. So I've been from in like last 3 to 4 years, I've been worked on several chips which have been used in self-driving cars, autonomous cars. For research, it is the chip that we worked on is being used by the scientists to in invent the gravitational waves. The Lego used it. Then all these Amazon Web Services, Facebook, Google, everyone use these chips in their backends. Even we are working with NASA to help people help them land in Mars by 2030 by using our real-time rendering and all this calculation stuff. So it is not like you are working on that completely, working with them. You may be working on one specific circuit inside that huge chip, maybe uh, around hundreds or thousands of transistors among that 54 billion transistors. Only that much you will be working on, but the end result that you are getting, if you see the big picture, which is like always exciting and allowed to be part of it. So that's one of the most interesting thing that I felt to be that good to be a part of an industry. And I think so. The yeah. So you can, if you have any questions, you can shoot right away. Again, we have some more time, so we just keep on doing this. So initially, we thought about a Zoom session where it'll be more interactive. It's like you can ask questions and stuff, but here it is. You can comment it. I can read and I can answer it if it is doable. So I think most of the stuff I have planned for is covered. So this is how I got into industry, and from once I get into industry like this, I started learning things which is not really necessary, because if I have something to do, I can do that and wrap it up. But I, after doing that, I used to learn about other things, whatever related to it. That is not completely necessary to understand that for doing your job, but it will definitely help you. That is actually that has helped me a lot in moving forward and progressing and going like that. So you should never stop learning. You should continuously keep learning things. So make that a habit, like you used to go to YouTube and start watching a video and then go and start watching and watching and watching and get lost in that world. So just spare some time to watch some videos like which will be useful to you, which is related to the industry or technology or whatever. It need not be a documentary kind of stuff, but just um, generic videos about the technology and stuff. Definitely, the things you will learn will be a lot. It will be a huge amount of things that you can learn by that. Is working in hardware more dynamic? I mean, software is just a programming, right? So it's thrilling new job. So it's you cannot say like that, because both these things should coexist. So without it's like you're designing this hardware, you have challenges based on the requirements. At the same time, from software perspective also, you have a huge amount of challenges. But one thing I can say is that is working on hardware, maybe because I like this more. But if you ask the same question to a software guy who likes software, the answer may be different. But I this working on hardware is more more interesting for me, because the it become more interesting when we found some issues from some behavior that is not expected, then debugging these things and find out more things about it in semiconductor level or in the much basic level. That whole process is very much exciting. Yeah, in software also it is similar. You can explore. There's a lot of things to be done, so you cannot say it is more dynamic than hardware or less dynamic than hardware. It is somewhat similar. It's all about your interest and your fascination about that stuff. So anything else that you guys wants to ask, then you can ask. So you cannot say. I mean, this hardware is more dynamic and software is just programming. It is like there are a huge amount of challenge in the software programming itself. It's not just writing a program to solve a thing. Considering this new artificial intelligence and deep learning and this neural networks stuff, it is very much exciting and very much dynamic. I don't agree with that question saying that hardware is more dynamic and software is just programming. I don't second that. So the only thing is, whatever you do, just uh, make sure you're doing in the best interest. You're doing things that, I mean, whatever you do things that you love, that do things that you like. Then you'll definitely find way to learn more things, understand more things about it, and you'll definitely, I mean, try to thrive in that. And you'll definitely make it a habit to understand things about it and doing this even in free time also. So that's the one most important thing that helped me, the interest I have towards the field and towards the technology in general. Mm, is there anything else? I am not exactly sure what you were expecting from this session, but I hope you got something out of it that will help you in pursuing your interests, whether it's in the field or outside the field. Definitely these things will help, whatever you are intending to, whichever field you are trying to get into. Learn more things about it, uh, which is like there isn't enough things that someone can teach you. The things that you can learn by yourself will definitely help you, whatever field it is. I know all people who end up learning this engineering or end up in a BTech degree won't be having interest to pursue a field in that itself. They will be having different interests. So that's perfectly fine. Everyone will have their own passion and their own interest, and whatever your interest, you should identify that and you should go behind it. You should understand more things, you should learn more things which is related to that, and definitely it will get you, it will get you somewhere good place in that field, whatever it is. So I think, yeah, so we are going through a hard time, the pandemic, and everyone is sitting at their home, hoping for the best to happen. So yeah, I was also working from home from last 2 months almost. I'm here Kerala only. I actually work in Bangalore. My office is there, so I came during March here, and I'm just stuck here. So I'm working from here for last 2 months. So hope you all are safe. You and your family, everyone is safe in your homes. So I think we can uh, wrap up the session. Yeah, I think it's almost an hour. If you have anything else, you can just ask me, or else I think we can wrap it up. If you have any questions to ask, it's not like you need to ask now itself. You can just send those questions to these who are organizers, who are doing this, ECSA representatives. Then they can send it forward, and I can reply to it. It's not limited by a session like this, so you can reach out to me anytime you want. It's not like, yeah, it's you need to wait for a session like this to interact. You can do it whenever. You can just reach out to me through social media or LinkedIn, Facebook, whatever you have. It's not a problem. Whenever I get time, I'll try to give replies. It's fine. So I think we can wrap up the session. Yeah, sure. I'll share the Facebook and LinkedIn ID. I'll share with these ECSA guys. They will send it up to you. No problem. So I think we can wrap it up. So everyone, stay safe. Take care of your family. Uh, that's it. I think. Have a nice day.